Everyone, I am Mahitha Mansoor K, studying MSc Computer Science in Manasa Gangotri. My topic is Decision Tree Classifier. Decision Tree Classification Algorithm. Decision Tree algorithm belongs to the family of supervised learning algorithms. Unlike other supervised learning algorithms, the decision tree algorithms can be used for solving regression and classification problems too. The goal of using a decision tree is to create a training model that can use to predict the class or value of the target variable by learning simple decision rules inferred from prior data. In decision trees, for predicting a class label for a record, we start from the root of the tree. We compare the values of the root attribute with the records attribute. On the basis of comparison, we follow the branch corresponding to that value and jump to the next node. Types of decision trees. Types of decision trees are based on the type of target variable we have. It can be of two types. Categorical variable decision tree. Decision tree which has a categorical target variable, then it is called a categorical variable decision tree. Continuous variable decision tree. Decision tree has a continuous target variable, then it is called continuous variable decision tree. Example, let's say we have a problem to predict whether a customer will pay his renewal premium with an insurance company. Here, we know that the income of customers is a significant variable, but the insurance company does not have income details for all customers. Now, as we know this is an important variable, then we can build a decision tree to predict customer income based on occupation, product, and various other variables. In this case, we are predicting values for the continuous variables. Important terminology related to decision tree. Root node. It represents the entire population or sample, and this further gets divided into two or more homogeneous sets. Splitting. It is a process of dividing a node into two or more subnodes. Decision node. When a subnode splits into further subnodes, then it is called the decision node. Leaf or terminal node. Nodes do not split is called leaf node or terminal node. Pruning. When we remove subnodes of a decision node, this process is called pruning. You can say the opposite process of splitting. Branch or subtree. A subsection of the entire tree is called branch or subtree. Parent and child node. A node which is divided into subnode is called a parent node of subnodes, whereas subnode are the child of a parent node. Decision tree classify the examples by sorting down the tree from the root to some leaf or terminal node with the leaf or terminal node providing the classification of the example. Each node in the tree acts as the test case for some attribute, and each edge descending from the node corresponds to the possible answers to the test case. This process is recursive in nature and is repeated for every subtree rooted at the new node. How do decision trees work? The decision of making strategic splits heavily affects a tree's accuracy. The decision criteria are different for classification and regression trees. Decision trees use multiple algorithms to decide to split a node into two or more subnodes. The creation of subnodes increases the homogeneity of resultant subnodes. In other words, we can say that the purity of the node increases with respect to the target variable. The decision tree splits the node on all available variables and then selects the split, which results in most homogeneous subnodes. Steps of how do decision tree works. It begins with the original set S at the root node. On each iteration of the algorithm, it iterates through the very unused attribute of the set S and calculates entropy and information gain of this attribute. It then selects the attribute which has the smallest entropy or largest information gain. The set S is then split by the selected attribute to produce a subset of the data. The algorithm continues to recur on each subset, considering only attributes never selected before. Attribute selection measures. If the dataset consists of n attributes, then deciding which attribute to place at the root or at different levels of the trees as internal nodes is a complicated step. By just randomly selecting any node to be the root can't solve the issue. If we follow a random approach, it may give us bad results with low accuracy. For solving this attribute selection problem, researchers worked and devised some solution. They suggested using some criteria like entropy, information gain, Gini index, gain ratio, reduction in variance, chi-square. Coming to the entropy. Entropy is a measure of the randomness in the information being processed. The higher the entropy, the harder it is to draw any conclusion from that information. Flipping a coin is an example of an action that provides information that is random. From the above graph, it is quite evident that the entropy is 0 when the probability is either 0 or 1. The entropy is maximum when the probability is 0.5 because it projects perfect randomness in the data and there is no chance if perfectly determining the outcome. Information gain. Information gain or IG is a statistical property that measures how well a given attribute separates the training examples according to their target classification. Constructing a decision tree is all about finding an attribute that returns the highest information gain and the smallest entropy. Information gain is a decrease in entropy. It computes the difference between entropy before split and average entropy after split of the dataset based on given attribute values. ID3 decision tree algorithm uses information gain. Gini index. You can understand the Gini index as a cost function used to evaluate splits in the dataset. It is calculated by subtracting the sum of the squared probabilities of each class from 1. It favors larger partitions and easy to implement, whereas information gain favors smaller partitions with distinct values. Gini index works with the categorical target variable success or failure. It performs only binary split. Steps to calculate Gini index for a split. Calculate Gini for subnode using the above formula for success and failure Q into P square plus Q square. Calculate the Gini index for split using the weighted Gini score of each node of that split. Gain ratio. Information gain is biased towards choosing attributes with a large number of values as root nodes. It means it prefers the attribute with a large number of distinct values. C4.5, an improvement of ID3, uses gain ratio, which is a modification of information gain that reduces its bias and is usually the best option. Gain ratio overcomes the problem with information gain by taking into account the number of branches that would result before making the split. It corrects the information gain by taking the intrinsic information of a split into account. Reduction in variance. Reduction in variance is an algorithm used for continuous target variables. This algorithm uses the standard formula of variance to choose the best split. The split with lower variance is selected as the criteria to split the population. Steps to calculate variance. Calculate variance for each node. Calculate variance for each split as the weighted average of each node variance. Chi-square. The acronym CHAID stands for Chi-squared Automatic Interaction Detector. It is one of the oldest tree classification methods. It finds out the statistical significance between the difference between subnodes and the parent node. We measure it by the sum of squares of standardized difference between observed and expected frequencies of the target variable. It works with the categorical target variable success or failure. It can perform two or more splits. Higher the value of chi-square, higher the statistical significance of differences between subnode and parent node. Steps to calculate chi-square for a split. Calculate chi-square for an individual node by calculating the deviation for success and failure both. Calculated chi-square of split using sum of all chi-square of success and failure of each node of the split. Advantages of decision tree algorithm. When using decision tree algorithm, it is not necessary to normalize the data. Decision tree algorithm implementation can be done without scaling the data as well. When using the decision tree algorithm, it is not necessary to impute the missing values. The data pre-processing step for decision trees requires less code and analysis. The data pre-processing step for decision trees requires less time. The concept behind decision tree is more familiar to programmers and comparatively easier to understand than other similar algorithms. Disadvantages of decision tree algorithm. The mathematical calculation of decision tree mostly require more memory. The mathematical calculation of decision tree mostly require more time. The reproducibility of decision tree model is highly sensitive as small change in the data can result in large change in the tree structure. The space and the time complexity of decision tree model is relatively higher. Decision tree model training time is relatively more as complexity is high. Single decision tree is often a weak learner, so we require a bunch of decision tree for called random forest for better prediction. Thank you.